Okay, so now what we're going to do is in this example, we're going to show you how to show, basically we're going to deal with showing that a function is continuous and differentiable at a point. Okay, so here's the setup. I've got the function here. Let me then read the setup and then we'll talk about it. It says a toy company wants to design a track for a toy car that starts out along a parabolic curve and then converts to a straight line. The function that describes the track is to have the form given on the board, where x and f of x are in inches. For the car to move smoothly along the track, the function f of x must be both continuous and differentiable at -10. Find values of b and c that make f of x both continuous and differentiable. So we need to find values of b and c that will make this both continuous and differentiable at x equal to -10. Now, it's obvious from the functions that both of these rules, both of these are polynomials, so we know they're continuous everywhere. So the only point that might be an issue with a piecewise function, well, with this piecewise function, is going to be at x equal to 10. Okay, so now, let's deal with continuity first. What do we have to do to show that it's continuous at 10? So we want to deal with continuity first. Okay? So, we need to make sure that the limits from the left and the limit to the right both get the same value. Okay, so what we want is we want the limit as x approaches -10 from the left. Now, if we're going from the left, we're using the top one, so it's going to be 1/10 x squared plus bx plus c. Right? We need to find that one. Okay? But since we know that these limits have to be equal, let's deal with the bottom one because there's no variables other than x. So, and we know where x is going. So as x approaches -10 from the right, we know we're going to use the bottom rule. So that's going to be -1/4 x plus 5/2. Okay? And so now what's going on here? Well, again, as we approach it from the left, because this is a polynomial, it's continuous everywhere, so we can just plug it in, and we know the limit as x goes to -10 is going to be what? It's going to be -1/4 times -10 plus 5/2, which is going to equal 5/2 plus 5/2, which is going to equal 10/2, which is going to equal 5. So now we know what we need this limit to be. This limit has to be 5. So in other words, the goal now is to find values of b and c that will make this limit equal to 5. So now we know where we're going. Let's find the limit of this thing. And again, this is a polynomial, so it's going to be continuous everywhere. So let's just plug in 10 into the function. And see, this is going to give us 100/10 plus 10b plus c, right? And so this is going to equal 10 plus 10b plus c. Now, we need these two to be equal. Let's set them equal to each other. So 10 plus 10b plus c is equal to 5. Okay. Where are we at? So now we just need to solve this. And in fact, let's just solve this for C. That's going to be the easiest one. So now, we're going to subtract 10, so we're going to negative 5. So, what do we get? We get C. So this implies that C is going to equal negative 10b minus 5. Right? So negative 10b, hold on a second. We're going from the right. I wrote something down wrong. Hold on, let me check here. Where am I? Five. Oh, I know why. Because this, oh, wait a minute, this is negative 10. Yeah, this should be negative 10. That's where I made my mistake. This should be minus 10 because I put in negative 10. Okay, so then this should be positive. This should be minus. And that's it. So this is going to be our C value that will make it continuous. So basically we just have to choose our C and B to make this true. And so there's going to be many, many different values, infinite number of values we could choose. So that's it. So that's how we make it continuous. So in the next video we'll tackle the question of differentiability. Have a good day.